Hey, what's up, y'all? How are you doing? I'm glad to be back. Some of you guys are out at the fair, so if you're at the fair, what's up? All you're gonna need is a periodic table, which should be at the beginning of your agenda. If not, pull up a digital one. I will have some in the slides, but again, pull up a digital one. Periodic table, totally cool. And then, yeah, just make sure to get this written in your agenda. We will have a journal check at the end of this week. Okay, let's just move forward. Hopefully you had a good weekend. I was at where was I at last week? I don't know, because I've been like so many places over this last month. It's crazy. But I was at sixth grade camp. Sixth grade camp was wild. I'm gonna post up a whole little whole little video about that at some point. But anyway, sixth grade camp was pretty awesome. And it was pretty good for the most part. A tiny bit of little drama at the end, but you know what I mean? It just is what it is. Is what it is. Everybody made it home safe, you know what I'm saying? So we're good to go. All right, let's move to the next thing. So you will be having a journal check at the end of this week, so it'll be number 12. There will be more stuff filled in as we go throughout the week. I just got to see how much we're going to do. We will have entry activities. So we will have several entry activities, but they will all be correlated to the state test. So the entry activities will be state test questions. You'll answer them, and then we'll go over them to kind of just practice, you know what I mean, and get you going there. And then also this week, we're going to just become I would say comfortable with the periodic table and kind of looking at it and how it works. So those are things we are going to do during this week, and then you're going to take the state test next week. So just holla at that. Okay, cool. Let's go here. I just want to say, hopefully you've been standing on business and you got all these things done already. So there was the page number 49. Right, and then there was the Lincoln Literacy, third trimester goals. Those are from like 2 weeks ago. You know what I mean? Not even last week, but the week before that. Okay, also this assignment right here, the lunar cycle at the very end. Make sure you got all this stuff turned in. I will say this. Please repeat after me. I will put my name on my paper. Yeah, I will put my name on my paper. That was an issue of people not putting their name on the paper, so hopefully you have done that. If not, look into the comments, and then come see me or leave a comment and let me know like what's up. And before you leave a comment, you should really read the comments I leave, because some people were really leaving comments, and I was like, hey, you should just read the comment that I left right above you to answer your question directly. So those are just some of the things I saw. Hopefully you guys were you enjoyed this. For the feel that I got from most of the students, that they enjoyed the movie, or they thought at least was okay. And hopefully just shows you, obviously this film deals with racism directly. It also deals with some sexism in the realm of science, but then also this idea that you can't judge a book by its cover, and the smartest person in the room is just the smartest person in the room. And you saw that Katherine Johnson ended up being like the smartest person in the room, and some of the people did not want her to check their work because she was black, but then also on top of that, it was really because she was a woman, right? And they were like, no woman's going to be smarter than me. But it turns out that she was actually the smartest person in the room, and a person who was needed and crucial. And these women were crucial to us being able to get on the moon. And hopefully you guys saw that idea that Sputnik, right, that Russian rocket is what really spurred America into this space race, and this idea that we've got to be first. And this is how we kind of changed some of the way that we did school, with more emphasis on mathematics and a higher emphasis on science and these kind of things. That's how a lot of these classes actually came about. They were born out of this idea that, okay, we need more engineers, we need more scientists, we need more mathematicians, because of the fact, right, that we're trying to make sure that our country is first and leading in innovation and everything. All right. So that's part of the reason why we actually have science class. So if you don't like science class, blame the Russians, okay? All right, just kidding. All right, but literally it is because of Sputnik spurred things to change. All right, now we're gonna do this in class, but you need to do this on your own. So check Canvas, check Aries, and then check your Gmail. Make sure that all of those things are good. We only got 5 weeks, so finish this joker strong. So we're just gonna go ahead and move forward off this. This is the list of assignments that were the last ones that were turned in. Those are the same ones I just showed. So hopefully you got all of those things turned in. All right, let's move forward. Blat out. We are not gonna do this one. Actually, I guess I'll do it. Would you rather be forced to watch a movie you hate over and over again for a week, or be forced to watch listen to a song that you hate over and over for a week? Now, just thinking of this and doing some maths, you're going to have to watch this into the somewhere between 65 to 80 some odd times, depending on how much you sleep. Over here, you're into the thousands. Now, at first I thought, oh, definitely going to watch because I got to watch less. It's not a big deal. But I also was thinking, you know how it is when you start listening to songs, even if you don't really like the song, eventually you kind of come around and you're like, oh, it's kind of a bop, just kind of a bop. Maybe that might happen to the song, even though I figured it's got to grow old listening to the same song. I was all getting tired right there. Listening to the same song. It's got to get old. So at least the movie, you'll be able to see different things. So I think I'm still going with the movie. I'm still going with the movie. What you going with? Leave a comment. Okay, so let's just talk about the states of matter. Hopefully this is familiar to you. We've got solid, we've got liquid, we've also got gas, and then we've got plasma, right? So then if you look at the solid, these right here are chemical bonds between the atoms. It looks very rigid. Everything kind of stays in place the way a solid reacts. If you look over here at liquid, you see these bonds, but they're kind of able to flow over each other. So bonds are broken and they're actually reestablished like very quickly. If you look in the gas, they're very far apart, and their chemical bonds are very weak. And if you look in plasma, it's very much the same thing. And the difference between gas and plasma is that these atoms are charged, which allows electricity to flow between them. And that's kind of this idea that you see with lightning. When you have charged like air particles or gas, right, then it allows electricity to flow through them. All right, cool. I do want you to write this down. What is matter? Matter is anything that takes up space and has a mass or weight. So these are the states that matter. These are the states that matter comes in, or that they can be in, right? But matter is anything that has a space, right? That takes up space and has a mass or weight. And when we say takes up space, we're talking about volume. So volume is just the measure of how much space an object takes up. So again, pause it if you need to, but we're moving forward. So I do want to say this: a solid, when it starts to melt, then it becomes a liquid, and then if it continues to heat from a liquid, it'll turn to a gas. That's called vaporization, or you may know that from the water cycle, it's called evaporation, right? And so I just wanted to put that out there. Also, sublimation is not one that we see a lot, but if you've used dry ice before, you've seen it turn directly from a solid into a gas. You can just observe that, right? So just some things. All right. Cool. So let's go ahead and move forward. Now, I'm like, what do you know about the periodic table? Do you know anything about the periodic table? Some people do, some people don't. And this is what a periodic table cell commonly looks like. Like, it kind of looks like the same thing here. Most periodic table cells kind of look commonly like this. And if you don't know much about the periodic table, some people said, oh, it has elements on it. Well, what are elements? People are like, I don't know, I'm not sure. You know, these kind of things. And that's okay. I'm just trying to see what is it that you guys know about the periodic table. So let's just start here. And this is as far as we're going to get for today. This is a basic periodic table cell. So I do want you to write this inside of your journal. So usually it will have the element name. So the element name in this case is carbon. The element symbol, which is right down there, it's a shorthand abbreviation for the element name. Usually they're the same, not always. Sometimes they are different, and the main reason that they are different is depending on if this element had a common name before the periodic table. So you see that with like iron, and we'll show that where iron has Fe as its symbol, it's because ferrium or ferrous, right, it already had a name for thousands of years before we ever even thought to put it together in a periodic table. Now, these numbers, we'll get to that. So the atomic number is the number of protons. You're probably like, what is a proton? Don't worry, we'll get there. So the number of protons in the nucleus of the atom, well, at least we know that protons are located in the nucleus of the atom, and its atomic number seems to be the count. So in carbon, there are 6 protons, right, in the nucleus of the atom. Now, the atomic mass is the average mass of the atoms in an element. And we'll talk about what that means. It's just that there's variations of carbon, right? Or what we call isotopes, right? We call them different little variations where they're slightly different. And we'll talk about how they're different once we get into the parts or the atomic structure. We'll talk about how they're different. But the average, on average, carbon with an atomic mass of 12 seems to be the most abundant, because when we average all of those masses together, 12.01, so that's very close to 12 as a whole number, means that is the most common version of carbon that exists here on the earth. All right, so that is everything here for today that we will cover. We will have more for you tomorrow. All right, y'all. Peace.